In this video, I'll show you how to find the area of a polar region. This is question number 3. The question reads, find the area contained inside the curve r is equal to 2 cosine theta, but outside r is equal to 1. What you see in blue is represented as r is equal to 1. And they want everything outside of r is equal to 1, but inside this, which is represented in red. So what they're looking for is everything from here to here and inside. Now to do this problem, what we have to do is find the area of the red and subtract by the area of the blue. Of course, you need to find where they intersect. So that's our first step. We need to find where they intersect, and that will represent our lower and upper bounds. Here's how to do that. We'll set this equation and this equation equal to each other. So I'll have 1 is equal to 2 cosine theta, and I'll solve for theta. Here's how. Dividing both sides by half, then taking cosine inverse of both sides gives us theta on the right side isolated, and I'll use my calculator for this, where I have cosine inverse of 1 over 2. We end up with pi over 3. Pi over 3, and that's our angle. So this right here represents pi over 3, and this also represents pi over 3, but in the opposite direction, so plus minus pi over 3. Our lower bound, therefore, will be negative pi over 3, and our upper bound will be pi over 3. Now the formula that you use to find the area contained within a polar equation is the following, where area is equal to the integral between a and b, and the integrand will be half r squared d theta. So like I said earlier, I'm going to find the area for the red circle and then subtract it by the area of the blue circle within these bounds. Essentially I have a2 minus a1 is equal to my final area, at. So we'll have to set up this equation twice, once for the red and once for the blue. Let's start with the red. We have the integral between negative pi over 3 and pi over 3, half times r, which in our case for the red curve is 2 cosine theta, all raised to the power of 2, minus, once again, the integral between negative pi over 3 and pi over 3, positive, half times r is equal to 1, remember? So we have 1 to the power of 2, which is 1. This one is easy, this one is a little harder. Next, we will find the integral of the easier of the two. The integral of this is, I'll pull out this half, the integral of 1 is theta. So we have 0.5 theta, and we need to evaluate this at pi over 3 and negative pi over 3. We'll do that later. Now we need to find the integral of this function. This is slightly harder to do because we first have to distribute this 2 to this factor and this factor, where we have 4 cosine squared theta. 4 times half is 2, and I can pull that out where I have 2 times the integral between the same bounds as before. And I have cosine squared theta d theta. Integrating cosine squared theta is hard because you need to use an identity instead of cosine squared theta to make it easier for yourself. The identity that I'm thinking of is the same identity that I used in question number 2 and question number 1, which is cosine squared theta is equal to half 1 plus cosine 2 theta. Instead of this, I'll use the following. Now that I've rewritten it, you'll notice that if I pull out this half, I end up with 2 times half, which is 1. So we have 1 on the outside, which I won't write. 1 plus cosine 2 theta d theta. And don't forget about this. I'm not going to rewrite it, but keep that in mind for later. The integral of 1 is theta. We already know that. And the integral of cosine 2 theta, we need to do a u sub here, where I set this equal to u and replace this part, d theta, with, well, first u is equal to 2 theta. Du is equal to 2 d theta. Solving for d theta, I have du over 2 is equal to d theta. So I'll replace this with du over 2, and I'll pull that out where I have plus 1 over 2, the integral within the same bounds, a and b. I won't write them out, it's repetitive. Cosine u multiplied by du. The integral of cosine u is sine of 2 theta over 2 plus theta. And we will evaluate this at pi over 3 and negative pi over 3. Now we can bring this back into the equation. Now that I've written it all together, I need to evaluate this part of the equation at pi over 3, and then subtract what I find with this part of the equation evaluated at negative pi over 3. And similarly, the same thing here. And if you do it correctly, you should end up with an area that's approximately 1.91 units squared. And there you have it. That is how to find the area of a polar region.